Hello, so today we will be discussing about projectile motion. Projectile motion. It is a very important topic for mechanics from which a lot of questions come into NEET exam. So first of all, let's start with what is a projectile? Any body which is given some velocity, which is given some initial velocity and is moving only under the effect of gravity. That is, there is no extra engine or fuel or other body which is applying force on it to keep it in motion, keep to that is change its acceleration or anything. It is moving only under the action of gravity. Such a body is called a projectile, and its motion is called projectile motion. The path the path traveled by such a body is called trajectory of the projectile. Trajectory of projectile. Now let's see how we can study it. As we can see here, if we are throwing some body with some initial velocity v naught at some angle theta naught from horizontal. Now how can we study it? It is a motion in a vertical plane. Why we can study is we use physical independence principle of independence of motion, which was given by Galileo first. What does it say? It says that the horizontal motion and vertical motion of the body are independent of each other, are independent of each other. This principle allows us to study any motion in a plane. Now, how can we use this? If we see this velocity is at some angle, we can convert this initial velocity into two components, one along the horizontal and one along the vertical. So the vertical component and horizontal component can be denoted by V naught y and V naught x respectively. So what is V naught x? V naught x is V naught cos of theta or theta naught, which is the initial angle. What will the vertical component at the start? It will be V naught y sine of theta naught, as we know from the resolution of vectors. Now, these two motions move independently. These two motions behave independently. It's not like the vertical motion has any bearing on the horizontal motion and vice versa. What happened along x-axis? Acceleration is zero. There is nothing which is giving acceleration if we ignore the air resistance and the likes. But in vertical axis, what we have? We have acceleration, which is gravitational acceleration. If we take the vertical upward direction as positive, as it usually the case for any Cartesian plane, so then what will happen? The acceleration will be actually negative because it is downward. So the horizontal component always remains constant throughout the motion, but the vertical component changes continuously due to this negative acceleration. Because the initial velocity is in upward direction, what will happen? This negative acceleration will reduce this initial velocity until eventually it reaches a point where it becomes zero, which is shown here. At this point, at the topmost point, the vertical velocity has become zero. After this, the velocity will change in the negative direction. But at every point, the x component remains same. Now let's see how we can study different properties for it. As this motion is here, first of all, we should know how its path will move. Now, what we can use, because we know that the horizontal velocity is constant. Horizontal velocity is constant. So the horizontal distance traveled denoted by x will be equal to the velocity in x direction, which we can see here is v cos theta. So we write v cos theta multiplied by the time taken. At first it is t0 and the total time of flight is denoted by capital T. So we can write it as capital T. Now, what about the vertical velocity? The vertical velocity, as we have seen, is v sine theta, which is in upward direction. Now let's use these to find the path of the projectile. We can use the second kinematic equation for uniform acceleration, which is s is equal to initial velocity into time plus half of acceleration into square of time. If we put that and we find that we use that for the vertical motion. So for vertical motion, the distance traveled can be denoted by y u. U is the velocity in vertical direction, which is v sine theta, the initial velocity in vertical direction at t0, multiplied by time, plus half acceleration. Now acceleration, as we see, is negative of g, multiplied by time square. Now this time, can we find this time from somewhere? Yes, we can. If we use the first equation, x is equal to v cos theta times t, we can derive from there time is equal to, from equation 1, we can find time is equal to x divided by v cos of theta. Let's put that value here. So what do we get? V sine theta into x by v cos theta minus half of g x square by v square cos square theta. Now further what we see, y is equal to x tan theta minus half g by v square cos square theta into x square. This equation, in this equation theta, for a given projectile, the initial angle and initial velocity are given, so they are fixed, they are constant. So if we see this tan theta is constant, let's denote it by p. So it will be, this term will become px. Similarly, gravitational acceleration, initial velocity and initial angles are constant. So when we put that, we can take that overall as a constant q. So it becomes qx square. So what we see, the equation for the motion is y is equal to px minus qx square. What does qx and y denote? These are any points on the trajectory. This is a equation for parabola. So the trajectory is parabola or is parabolic. So this is the first relation that we see, that trajectory of a projectile motion is parabolic. Now, there are different things that we will be interested usually in finding. What are these things? What is the maximum horizontal distance that the projectile has traveled? That is called as range. What is the maximum height that the projectile can reach? That is called maximum altitude. Also, the total time taken in the by the projectile to start from initial point and return back to the same horizontal plane. So that is called time of flight. So these are the three things we are usually interested in. Also, the time taken to reach the maximum height. So let's try to find them one by one. So first, let's start with time to reach maximum height. Maximum height. Let's denote it by capital T subscript M, time to reach maximum height. Now, how can we find the time at maximum height? What we see at maximum height, the velocity in projectile motion, as we see that vertical direction, there is gravity in downward direction. So at the topmost point, this topmost point, let's call it HM, maximum height, the vertical velocity becomes zero. The vertical velocity becomes zero. So we can use the first kinematic equation for uniform acceleration, which is final velocity is equal to initial velocity plus acceleration times t. Final velocity, as you can see, is zero. U means the vertical velocity, that is Vy. A is negative g, and time is Tm that we want to find. What will this give us? This will give us time to reach maximum height is equal to vertical velocity, initial velocity divided by g. What is vertical initial velocity? It is v sine theta if angle is given from the horizontal. So v naught sine theta divided by g. This is our formula to find the time taken by the projectile to reach its maximum height. We use this limiting condition that vertical velocity is zero. Next, let's find the total time taken. This was only to reach the maximum height. What will be the total time, which is called time of flight, as it shows that for how much time the projectile was in motion before reaching the original plane. That is something like in flight. Now, how can we find this thing? We see that in vertical direction at the start and at the final point, the projectile is at the same vertical height. So if we use the second kinematic equation, which is distance is equal to initial velocity times t plus half at square. So in vertical direction, what is the motion? Y. Initial velocity is v naught in y direction. Time is time of flight minus half g time of flight square. Now, what we see that if we put values, vertical motion is 0. Vertical direction motion will be our v naught sine theta for vertical direction. Tf we got minus half g tf square. What we can do, we can transpose the second, there are two terms, so the negative terms to one side, we get half into g tf square is equal to v naught sine theta times time of flight. Then we simplify it. What do we get? We get 2 times v naught sine theta upon g as the total time of flight. Right? If we compare it with the time to reach maximum height, what we see, it was v naught sine theta by g. So we can write it as time of flight is double of time to reach the maximum height, which is expected, because as much time it will take to reach the maximum, that same time will it take to come backwards, to return to the same horizontal plane. The next thing of interest is, what is the total height, the maximum height? So the maximum height itself, hm. Okay, so again we will use the same condition that at maximum height the vertical velocity is 0. The vertical velocity is 0. This time let's use the final, the third kinematic equation. So v square minus u square initial velocity square is equal to 2 times acceleration into distance. Now what is the final velocity to reach there? 0 minus initial velocity. What was the initial velocity? Initial velocity was V naught sine theta, because we are talking about the vertical motion. Okay, vertical is equal to minus 2 times g, and distance is maximum height that we want to find. So from here we simplify, transpose the terms. What do we get? We get V naught square sine square theta divided by 2g. This is the formula for the maximum height. Next we need to find the range. What is range? Range means the total distance traveled on the horizontal plane by the projectile. How can we find that? We know that in x-axis, along x-axis on the horizontal, there is no acceleration. So the velocity is constant. So we can use the simple relation that distance is equal to speed into time. So when we do it along x direction, what do we get? The range r is equal to speed. What is the speed? V naught cos theta according to the vector resolution multiplied by time. Time is the total time taken. Now we just found time of flight 2v naught sine theta by g. So we just use that 2v naught sine theta by g. On further simplification, we get v naught is squared 2 sine theta cos theta divided by g. Now here we have to apply the trigonometry portion of the maths. So we get v naught square sine 2 theta by g. This is the formula to find the maximum distance traveled in the horizontal plane if the projectile starts and returns to the same horizontal plane, which is also called range. Right? So these are the formulae on basis of which we see different questions. This is a very important topic, as a high weightage. So let's solve some previous year questions so that we can understand them properly. So with each questions, we will get some new concepts. So let's first start with the first question, which will tell us about the maximum range. So we will see a condition for angle. A missile is fired for maximum range with initial velocity of 20 meter per second. So we know that initial velocity is 20 meter per second, and g is taken to be taken as 10 meter per second square. We have to find the range of the missile. First of all, maximum range. Maximum range means that the range is maximum, but what decides the range? What decides the projectile's trajectory? Two things: the initial velocity and the angle of projection. Out of this, initial velocity is given fixed. We need to somehow find the angle. Now let's just write the formula first. So range is equal to what? V naught square sine 2 theta by g. When will this be maximum? To find maximum, this whole thing should be maximum. Now v naught and g are constant. What can be changed? Theta. So this means that 2 theta is to be maximum. When is 2 theta, sine 2 theta is maximum. When is sine 2 theta maximum? When sine 2 theta is equal to 1. Now we know that gives us sine 90, which gives us 2 theta is equal to 90, which gives us theta is equal to 45 degree. So this is also a condition that we always have to remember. The maximum horizontal range is always acquired when the angle of projection is 45 degrees. So these questions also clears the concepts. Now let's just find the value. Now it's just simple calculation. V naught square sine 2 theta by g. In this case, whenever there is r maximum, what will happen? We will always get V naught square by g, because sine 2 theta has to be 1. We put the values 20 square by 10, which gives us 40 meter. So option number 1 is the correct answer. So such questions has also comes in competitives in MCQ. What is the condition for maximum range? So that answer is that angle of projection must be 45 degree. Now the horizontal range and the maximum range for a projectile motion are equal. So here we have to find a relation for the angle of projection. So let's see. Horizontal range means just that maximum height. It's just another name. Horizontal range will be our r and maximum height are equal. So we just need to write the formula. What was the formula for maximum height? We got v naught square sine square theta by 2g. While range was, we just used that it was v naught square sine 2 theta upon g. So we have to find the relation for theta somehow. What we can do? We can simplify. V naught square on both sides gets cancelled. G and G gets cancelled. What do we get? We get sine square theta is equal to 2 times sine 2 theta. Now again we will have to apply the trigonometry. So we get 2 sine 2 theta is 2 sine theta cos theta. Other side we have sine square theta, so 1 sine square theta and that cancels. We get sine theta is equal to 4 into cos theta. I'm just doing it in the next phrase here. So what happens? If we take cos theta to other side, we get tan theta is equal to 4. Tan theta is equal to 4. So that makes us theta equal to tan inverse. Theta is equal to tan inverse of 4. And that is our condition. So whenever we want the range and maximum height to be equal, the angle will always be this specific angle, tan inverse 4, no matter what is the velocity or what is the shape or size of the projectile, if it is only moving under the action of gravity. So that's it for this class.